Hi everybody. This video is going to show you how to calculate an analysis of variance using Google Sheets, and there's a couple of really neat tricks in Google Sheets to make your job a little bit easier. This will be helpful on the homework assignment question where you have to calculate ANOVA by hand. Let's go ahead and look at a sample problem. In 2012, a very small sample was taken from the GSS, and the respondents were asked about how many hours of television they watched every day and what their highest achieved academic degree is. I've divided these into three different groups. Group number one are people that have less than a high school degree or less. Group number two are people with a junior college degree. And group number three are people with a college degree or more. The numbers in the table below show you the number of hours that each of those respondents watch television. If you look at the table on the right, you can see that there are 8 individuals in each group. You can see the average number of TV hours. So for people with less than a high school education, they watch television on average 4.75 hours. For people with a junior college education, they watch television 1.88 hours. And for people with a college degree or higher, they watch television on average 2.25 hours. To do an ANOVA problem, we have to solve 4 variances. We need the variance for all the television hours, everything from everybody in the high school, less than high school, the junior college, and the college group. We also need the variance for everybody within their group. So we need the variance of just the high school or fewer people. We need the variance for just the junior college people, and we need the variance for just the college and greater people. And finally, we'll calculate the between group sum of squares, but I'm going to do that by subtraction because we know the variance for all the cases minus the variances for the within group is equal to the variance for the between groups. Let's hop over to a Google Sheet where I'll show you how to enter the data, put them into a format that'll be relatively easy to calculate ANOVA, and then we'll go ahead and solve for all these variances and complete our ANOVA table. So here's my Google Sheet, and in column A and B I'm going to enter the information for highest academic degree achieved, and in column B the television hours. So the first thing I'm going to do is just go ahead and type in some labels. Then I'm going to go ahead and just type in the numbers, and I'm going to speed this up a little bit, but here's what it looks like. Okay, with the numbers entered, I actually like to clean up my spreadsheet a little bit. I'm just going to go ahead and highlight all these columns and rows by clicking in this box up here, and I'll double click on this divider, and that's going to make my columns a little bit smaller. And then I'm just going to go ahead and make these different colors by filling them in, so we can fill in kind of a light red here, and for junior college we can fill in maybe a light green, and for college and greater maybe we'll use some kind of light blue. This just helps me remember that while I need the variance for all of the television hours, I also need the variances for the group coded red, the less than high school, the group coded green, and the group coded blue. Now I'm going to go ahead and start my ANOVA table. I'm just going to come over here just kind of move over a couple of columns, and I'm going to have a source for the sums of squares, and it can be between, within, and total. Then I'll have a column for the sums of squares, a column for the degrees of freedom, a column for the mean squares, an F-statistic, and a p-value. So this is the template that we're going to fill in all the numbers. The most important numbers right now are all those sums of squares. Now I'm going to show you a nice little trick here in spreadsheets. If I go to Data and click on Named Ranges, I can highlight a range of numbers or values and give them a name and then refer to the name later on. So if I just highlight this column of television hours, and I click Add a Range, I can now give it a name, and I'll call it TV Hours. I'm going to make a little column over here called Means, and let's call this the grand mean. And now I'm going to take advantage of that named range and used a function. So I'll type in equals average TV hours. You can see that I got the number 2.95, and that's the overall average for all the television hours. I'm going to need to calculate the means for the less than high school, the junior college, and the college and greater. And to do that, I'm going to go ahead and highlight just these small ranges and give it a name. I'll call this high school, and this green range I'll call JC, and the blue range I'll call college. And then I'm going to go ahead and figure out these averages. It helps if you spell average correctly. With all the averages done, I can now go ahead and start calculating the different sums of squares. Over here, in this column, I'm going to calculate the deviation of the value 1 from the overall or grand mean, and then I'm going to square it. And when I get that done, I'm going to copy it to the rest of the cells, and when I sum it, I'll have my total sum of squares. So my formula starts with an equal sign. I'm going to add a parentheses. We're going to take the first value for TV hours minus the grand mean, and one trick here is when I hit the F4 key, you can see it inserts dollar signs in front of the letter and the number indicating the row and the column, so that when I copy this, it doesn't move the address, it uses an absolute address. If your F4 key doesn't work that way, you can type in the dollar signs by hand, but you definitely need the dollar signs. And then I'm going to take that difference and square it. And then I'm just going to copy that all the way to the bottom. And that gives me my squared deviations. And now I'm going to use another function, and we're going to sum this column of numbers to get my total sum of squares. So there's step 1. Now I only need to calculate either the within or the between sum of squares, and I can calculate the other one, using a differencing method. So I'm going to go over here, I'm going to do the within group sum of squares next. And to do that, I have to calculate the variance of each of these scores within their groups. So again, I'm going to use a formula, equals, and we're going to go ahead and take this cell number, the cell value, minus high school. Again, I'm going to hit the F4 key to make this an absolute address and square it. And then I'm just going to copy this for all the high school people. Then I'm going to do the same thing for junior college. And for college. Now the sum of these numbers should be my within group sum of squares, so I'm going to use that sum function and just highlight this column of numbers, and there's my sum of squares. I don't need these two columns anymore. I don't need them visible, so I'm going to highlight them and use the drop-down menu and hide them. If I were to delete them, then the numbers in my ANOVA table would disappear, so I don't want that. So I'm just going to hide them so that my output is a little cleaner. Now I can calculate my between group sum of squares, which is equal to my total sum of squares minus my within group sum of squares. And now I need my degrees of freedom. I'll just show you, this is a small problem, but I'll just show you there's a couple of other nice functions in the spreadsheet. I can use the count function to count all these valid values and subtract 1, and that gives me my degrees of freedom for the total sum of squares. My between group sum of squares is equal to the number of groups, which is 3 minus 1, or 2 degrees of freedom. And my within group sum of squares is equal to the number of cases minus the between group degrees of freedom. So that's going to be equal to the count of these cases minus 3. And notice that those degrees of freedom add up. From here on out, it's just a matter of getting the right divisions. So my mean square between is equal to my between group sum of squares divided by its degrees of freedom. So equals this cell divided by this cell. The within group sum of squares is the exact same thing, so I can just copy this formula by dragging it down. My F-statistic is going to be equal to the ratio of these two mean squares. And then I can calculate a p-value using another function called F-dist. And F-dist works by picking the F-statistic and then the degrees of freedom between and then the degrees of freedom within. And there's my p-value. Now I'm going to go ahead and take these numbers and I'm just clean things up a little bit. I don't need all these decimal places. And I can highlight all this and double click again just to make the columns a little closer, and I have my F-statistic, and here you can see that the F-statistic of 3.804, if we have alpha equal to 0.05, is statistically significant because the p-value is less than 0.05. If we had picked a p-value, an alpha value of 0.01, we'd fail to reject the null hypothesis. So, to summarize, in an ANOVA problem like this, you need to calculate, since we have 3 groups, you need to calculate 4 variances. The variances for your dependent variable without group membership, the variances for all the within group numbers, and to do that you need those means and their deviation squared, and then you just build your ANOVA table. Along the way, we learned a little bit about absolute versus relative addresses, and we learned about using named ranges to make life a little bit easier. Hopefully you found this video helpful and it helps you with your homework assignment.